Right, good morning. Advent of Code 2021 Day 4. I'm taking a slightly different approach to reading the input today. I've written a template program that will read the input line by line and stick it in memory at address, or starting at address C000 hex, and then the actual program that solves the problem will read it out of memory. So the thinking there is that the time it takes for me to run one test of the program will be a lot less because I don't have to read the input file every time. Anyway, I'm a keen boy again today, so I'm up in time for the puzzle unlock. A giant squid on the submarine. Ugh. Okay, so we're going to get a bunch of bingo boards. And we have to work out which bingo board wins. There's 5 numbers per line. Every 6th line is blank. I changed my AOC program so that it tells me the size of the input, which should make it easier to guesstimate things like how much memory it's going to take. So there's 500 boards. No, sorry. There's 100 boards of 25 numbers each, so there's 2,500 numbers. And I've just realized that if the program I've got that reads the input is called input.sl, then it's going to overwrite the input, so we'll call that read.sl. So I think we use scanf instead of reget. What was the first? Okay. Maybe we'll just stick integers directly in memory, and then the other program is responsible for working out where they are. So actually that can just go to ptr. So we just read any amount of white space followed by an integer, stick it in memory. Okay. And what was the first line of input all about? Is that just the numbers, the bingo balls that are available? Oh, that's the order in which the balls come out. Okay. So the first line only contains the order in which the balls come out. So, oh man, maybe we just pass that from the file. Yeah, that's what we'll do. So let's try this. What we'll do is we'll have read.sl read all of the boards, and then part 1 and part 2 we'll still have to read the order that the balls come out. I did the thing where I typed Control D thinking I'd get back to my editor, but the editor was gone. Okay, so now if we read input.boards, that should read that file into memory, which it's doing now. And then we'll make sure. Oh, that doesn't actually take that long. Maybe this whole idea is a big waste of time. So can't remember how many there were. Okay. So I'm just going to print out the numbers. So this would be input I plus plus, j plus plus. So that will just check that we're reading the input properly. Great, well, it looks like it's worked. So input then was 2,500, wasn't it? So I've added an assert function since yesterday. Okay. Right. So now, how does bingo work? We read in balls, so we don't need any of this. We read in balls. In fact, we don't even need to store all the balls. When we get a ball, okay, we want to know which board, how many balls each board has matched. Can a board have duplicate balls? I'm guessing no, otherwise you'd just put the same ball on every square. So for each board we want to know whether it has, there's a 100 boards, aren't there? How many balls it's had, and once it's had 25 balls, we know we're done. So once we've read in a ball, we'll set I equals 0 less than 100 is the number of boards. Seems a bit bad to be hard coding all of this because it's going to be hard to put test cases in, but yeah. Where was I? No, well, I was less than input len. If input I equals ball, then this board gets another point, and then if any boards are complete, then we're finished. So then and what did we have to print? It was something multiplied by 25. Is it the sum of numbers in that grid? Sum of all. Oh, at least one complete row or column. Okay, yeah, we don't have to fill the whole grid. Okay, that makes it more difficult. What we'll do is switch on the like high bits of the matching numbers. Well, it doesn't need to be very high. So now we know any position that has the 0x100 bit set has already been drawn, and now for each board we need to go over each row and each column. So for line, so we'll have a J, we'll have a J. If there's a line starting at board plus I plus J, with a stride of 1, then we have a, no, we'll do J equals J plus 1. So board plus I plus J gives us the numbers on the top row of a board. So they want to have a stride of 5, or there's a line on board plus I plus 5 times J, and multiplication is really bad, so we'll avoid that. Board plus I plus J 5 is the start of a line, and then we want a stride of 1. And if we've got that, then so we need a couple of functions. One will we'll take a starting pointer and a stride and work out whether all 5 of the numbers starting at that pointer and going in that stride have the 100 bit set. And answer will take a pointer and a ball, sum up the values multiplied by the ball. So So if they all match that, then we're done. We return 1. We've got a line. The answer we need the big int for, I expect. Oh, do we? 6 numbers. They're each about 100. 100 to the power of 6. Oh no, sorry. 600 multiplied by 100. 60,000. Okay, I don't think this is going to overflow, but it might be unsigned. Did we want a sum of all the numbers in the grid, or just the numbers in the line? All unmarked numbers on that board. Okay. So at most we can have 20 unmarked numbers of an average of, well, let's say 20 numbers that are 100, and the ball we called could be 100, so it could overflow. We'll use a big int just to be safe. So Need to remember to turn the top bit off. So that gives us the sum of, no, only if the top bit isn't there. So in that case, we actually don't need to turn the top bit off because we already know it's not there. So that's the sum of all unmarked numbers. And then we want big new sum multiplied by the ball, and then output, which is sum ball b, and then we exit. I think that might be it. Any assertions we should add? Yes, I keep doing that, don't I? Maybe I should just rename rename the variable in the library. Oh, I've just realised a massive blunder. By storing all the numbers in memory, I'm not allowed to modify them in place. So I shouldn't be switching the 9th bit on. Yeah, okay, fine. That's wrong anyway. What a blunder. So what I'm going to have to do is at the start turn them all off. Okay. Right, so that'll be fine. Now the problem was the sum was 0. Do I need to do that? Surely not. Oh, that should be a B. Didn't that say 0 though? Why would B be 0? B should be a pointer. Okay, so that is the first number, so the problem is it thinks it's got a line where it actually hasn't got one. So got line is saying yes, where it shouldn't. And in fact, let's have that in hex as well. So that will tell us the pointer. Is this going to have a lot of spam? Okay. Those P pointers are not pointing into my board. So when we call got line, board plus I plus j. Oh, board. We don't need board at all anymore, do we? It's input, not board. Yeah, okay, fine. How long would we expect that to take? We've got 100 balls. No, sorry, we've got 100 grids that each have 10 lines across them. So that's 10,000 lines per ball. I might give it a little bit longer. Great. So by way of a progress indicator, I think we'll it was 0 times 12. So the sum of the unmarked numbers was 0 again. The sum of the unmarked numbers. Well, let's have our debugging back. That doesn't look right, does it? Why is every number 111? That's definitely not right. I'm going to make it reread the input. I think this idea of trying to save time by reading the input into memory and then leaving it there is probably not a good idea. Maybe just because I don't have enough practice with it. Oh, no, that's wrong. Why are they all 1, 1, 1? Also, if it is 1, 1, 1, why is it stepping forward from C068 to C262? Why doesn't it start at C? Oh, I know why. Yeah, because the first number is 17, so of course all the ones that are set are 17. Okay, so that might be right. Yeah, okay, fine, got it. That is doing the right thing. Do we go past the end of the first line of input? Yeah, there are no zeros in the first line, as far as I can see. Although it is wider than the screen. Wow, this is not an effective way to get the first line out. I'm going to cat it and type Control-C shortly after it starts. And then hopefully most of it should be missing. Some of it's missing. What would be a more effective way to delete all but the first line? I don't have a head command. I don't think I can. No, I don't think my editor has a better way to do this. It might have been faster if I started at the end, because deleting a line from the top is linear in the number of remaining lines. So if I'd started from the last one, it might have taken a lot less time. So there is 1 0 in the list of balls, but not a bunch of consecutive zeros. 17, 11, 37, 7 is what we're expecting. No, so that's wrong. Oh, I know why. It's my scanf bug again. Scanf reads one more character than you asked it to, so if I just tell it not to read the comma, then that should do the job. This stuff, I think this stuff's right now. It also occurred to me that instead of this business of marking off the 100 bit on the board, we can just have a little array that says which numbers we've already got, which will both be quicker and obviate the need for fixing the input at startup. Okay, let's try that. Good damn. So, why could that be wrong? So I'm going to do the thing about having an array that says which numbers we've got. I think they're all below 100, aren't they? And then after we've run it once, we can get rid of this little loop. Let's try that, shall we? Yes. Let the giant squid win. Okay, which board wins last? That's actually easier than part 1, given that we've already got part 1 to use. So we just need to keep track of which boards have won. Keep track of probably just how many boards have won. No. Which boards have won? So one more winner, and then after this, if number of winners equals 99, then we have to find which one hasn't won yet and know that that one will win last. Ah, no. What we'll do is we'll keep track of this as we go. If we haven't won yet on this board, then we'll check it. Because the score of a board changes based on whether it's won or whether we merely know that it's going to be the last one to win. And if the number of winners is now 100, then we print out the answer for this one. Is that the form of input to the answer function? Yeah, so I think that might be it. However, prior experience leads me to expect that it will not. Oh, it's getting faster because I don't have to check so many boards. Yeah, first try. Okay, good. Well, at least part 2 went quite well. What did we learn? Number 1, this business of reading the input into memory and leaving it there works, and it's definitely one to keep in my back pocket, but probably it's more risky than it's worth. Especially so on day 1 we were passing a lot of numbers from standard in, and it was very slow, but I made base 10 number passing much faster since then, and especially using the buffered input, reading in a bunch of numbers and passing them with scanf %d is actually fine. So I don't think I'll be doing this read numbers into memory thing every day, although if there's a day where reading the input is particularly expensive, we could do. The other thing was, maybe it's worth trying to fix the scanf bug. So the problem with scanf is where you scanf %d comma, it will read it has to read a character and then look at what it's expecting from the format string. So it reads, let's say you're passing 99 followed by a comma followed by 100. So it reads the first 9, the format string says %d, so then it's like, okay, well, I've got a digit, I'll keep reading while I've got digits. So it reads the other 9, turns it into a number 99, sticks it in your pointer. Then it reads the next character, which is a comma. Then it reads the next character of the format string, which is a comma. So it says, okay, that's good, that matches. Then it reads the next character, which is something else, and then it realizes it's reached the end of the format string. So I just need to make it know that it's reached the end of the format string and not read the next character. But yeah, fine. And I think some of the code was quite bad today. So let's see. Yeah, I don't like all this having two different numbers to keep track of j, but it's better than doing a multiply every time. Yeah, pretty dumb if we forgetting to increment p here. I feel like I've done that quite a few times. Maybe I need, don't know, maybe I need a for loop construct so that I remember to put all my increments in. This doesn't need to be here anymore. Well, I think the thing about putting the input in memory is very fun, and actually I'm curious if it will still be there across a power cycle. So I might test that in a second. Oh no, that's not what I meant. Cancel. So we don't need this. Don't need this. Using the stride, I think, was quite a succinct way to write the got_line function. These don't need to actually show the thing, do they? They only need to show the output. Yeah, this I and K business is kind of unpleasant. But again, it's because otherwise we'd need to do a multiply. And what did I want to look at? I think, oh yeah, in part 1 I wanted to delete the excessively verbose answer output. I know I haven't recompiled it. Just checking what the output looks like. And then I'm going to turn the computer off, run it again and see if it still works, because if it isn't turned off for very long, then the memory may retain its value. So you won't actually see it go off because you're seeing the output of a serial port, but maybe I will turn the camera around. So it's going off. I'm going back on. Now, what do we reckon are the chances that the memory retained its contents? Oh, it looks like it might have done. Otherwise, it would have failed the assertion that the length is 2,500. Yeah, cool. I wonder how long it keeps it for. Anyway, that was fun. Thanks for watching. Goodbye.